Hello everyone, and welcome to 7th grade Math Module 4, Percent and Proportional Relationships. In this video, we're looking at Lesson 4, Percent Increase or Decrease. Our learning goals to make sure we can calculate percent change. This will help us to master Standard 7 RPA1, compute unit rates associated with ratios of fractions, including ratios of lengths, areas, and other quantities measured in like or different units, and 7 RPA2. Recognize and represent proportional relationships between quantities. Calculating percent change is very similar to calculating with regular percents. The big difference is how we look at how our percents change. So we can replace our part in our percent change with how much our amounts have changed, which we can find by doing the new minus the original. And our whole is going to represent the original amount. Our percent then can tell us how much our amount increased if it is positive, or how much it decreased if it is negative. So if we had a smaller new and a larger original, then we would have a negative number for our change, which would be a decrease. So to help visualize how percent change works, we've got Cassandra's 5 rings here in this box. And this double number line diagram shows us the percent that each ring is out of the total. So 5 rings is the whole thing, which means that one ring is just 20% of that, 1 out of 5. And then our numbers increase, so 2 is 40, 3 is 60, 4 is 80, 5 is 100. So that 100% is our whole collection of rings, and each one is just the 20%. John increased his trading card collection by 5 cards. He originally had 15 cards. What is the percent increase? So to calculate this, we need to take how much his collection changed, which was the 5 cards, and then put it over our original amount of the 15 cards that he had. And we can use that to calculate our percent. So whether you're using the triangle of doing part divided by whole, or whether you're using this proportion, you would find that the percent that you get with 5 over 15 is 33 and 3 repeating percent. Suppose instead of increasing the collection by 5 cards, John increased his 15 card collection by just 1 card. Will the percent increase be the same as when Cassandra's ring collection increased by 1 ring from that first example? Why or why not? So let's first figure out what John's increase would be and then compare it with what we got in that first example. So instead of increasing it by 5, our change this time is just the 1 card. And our whole is still the same as 15, so we're doing that part divided by that whole, that change divided by our original. And we find that 1 over 15 is 6 and 6 repeating percent. So if we go back to that previous problem here, each of our rings represented 20%. So if we increased it by 1 ring, we would have another 20% on this number line. So it would have increased by 20% to add 1 ring. And that's a lot larger than our 6.6%. And that makes a lot of sense because we are taking our change and dividing it by the original. So since in this problem our original was greater, 15, our percent would be a lot smaller than if we had a less denominator for this fraction. For the remaining problems, please feel free to pause the video after we read the problem to try to solve these problems on your own. Ken said that he's going to reduce the number of calories he eats during the day. Ken's trainer asks him to start off small and reduce the number of calories by no more than 7%. Ken estimated and consumed 2,200 calories per day instead of his normal 2,500 calories per day until his next visit with the trainer. Did Ken reduce his calorie intake by no more than 7%? Justify your answer. Now we have 2 ways we could go about solving this problem. We could either figure out what 7% would be of his original and then reduce to see what his new amount of calories would be and compare them, or we could just try to find the percent change. I like the idea of finding the percent change. So what I'm going to do is take the new number of calories, which is 2,200, and subtract away the original, which is 2,500. That is our part, what I get when I subtract those. That's how much it changed. And then I'm going to put it over our original amount. So when I do that subtraction, I find that I have negative 300 as our change, which shows that he decreased 300 calories. And then I just take that part and divide it by that whole, or I can do cross multiplication to find that he decreased by 12%. And 12% is a lot more than 7%. So in this case, he did not follow his trainer's advice. The population of cats in a rural neighborhood has declined in the past year by roughly 30%. Residents hypothesize that this is due to wild coyotes preying on the cats. The current cat population in the neighborhood is estimated to be 12. Approximately how many cats were there originally? So you can pause and try this one here. Now, if I use that proportion of new minus original over original, I would need to know what my original number was to set that up. So if I plugged in what I did know with my new and my percent, I'd end up with this really complicated looking problem that has two variables, and while we could solve it, it's really complicated, and it kind of makes me feel sad to try to solve something like that. So let's see if we can break this down and think about percent change in a slightly different way. So I have a tape diagram here showing the entire tape diagram is our 100% that represents our original number of cats, because that 100 and the original are both in our denominators there. They go together. And I know it decreased by 30%. So if it decreased by 30%, that means there has to be 70% left. And I know that that 70% is 12 cats. So instead of doing my subtraction in my part, I can instead do my subtraction with my percent. So my whole is still my original. In this case, my part would be my new amount, and then I would need the percent that represents that new amount, which I can get by taking 100%. And in this case, since it's a decrease, I can subtract away that percent to find out what the percent of my new amount is. So once I have that, I'm just doing a regular old percent problem because I did my subtraction with my percents. So now I can set up a lovely little proportion or use one of my other strategies where I plug in the 70% and then my part would be the 12, because again, the whole in this tape diagram is my original and that 12 is my new. So now I can either cross multiply to solve this proportion, or if you are somebody who prefers using a triangle or algebraic equation strategy, we would take our part of 12 and divide it by our 70%. With cross multiplying, we would end up multiplying the 12 by the 100 first and then dividing it by the 70 to find that our percent, or sorry, not our percent, our original comes out to, it's about 17.1. The number keeps going, but we can't have part of a cat, so about 17 cats. What does this video make you wonder about solving equations for percent increase or decrease? Write your questions down so you don't forget them. Then you can try to find answers online or ask a classmate or teacher. Thanks for watching, and when you're trying this on your own, remember, if you learn from your failures, then you succeeded.